It's a revolution for Intel, and clearly it's a unique way for us to do. First of all, we push the limit of the design and also in the process technology.
For decades, one name dominated the computer chip industry with unmatched authority. Intel didn't just make processors, it defined what computing meant. But somewhere along the way, the giant stumbled. This is the story of how a titan lost its throne and what happened when it tried to fight back. In the 1990s, Intel controlled 90% of the personal computer processor market. It was the undisputed king of silicon, the company that literally powered the digital revolution. When you turned on your computer, chances were overwhelming that an Intel chip was doing the heavy lifting inside. The company held its position as the world's largest semiconductor manufacturer by revenue for nearly 3 decades. But by 2024, Intel had posted a staggering $16.6 billion quarterly loss. Its stock had plummeted by more than 60%, and it had been kicked out of the Dow Jones Industrial Average, replaced by its competitor, NVIDIA. The decline wasn't sudden. It was a slow unraveling built on a series of missed opportunities that would haunt the company for years. The first major misstep came in 2007, when Apple approached Intel about supplying chips for a new product called the iPhone. Intel's chief executive at the time, Paul Otellini, turned down the deal. He didn't think smartphones would be a high-volume business. He believed the profit margins were too low to justify the effort. Apple went with chips based on ARM architecture instead. Today, ARM processors power more than 95% of the world's smartphones. Intel missed out on the entire mobile revolution because it couldn't see beyond its traditional business model. But the company made an even costlier mistake in the late 2000s. As the artificial intelligence boom began to take shape, Intel had another golden opportunity. In 2017, OpenAI approached Intel about a partnership. For just $1 billion in cash, Intel could have acquired 15% of OpenAI's shares. If the company had been willing to provide hardware at cost price, it could have secured an additional 15%, giving it a 30% stake in what would become the company behind ChatGPT. Intel's leadership at the time believed it was too early for AI to enter the market. They thought the investment would lose money. They passed on the deal. Years later, the artificial intelligence revolution would be powered primarily by graphics processing units from NVIDIA, not Intel processors. Intel's struggles with graphics processors went back even further. In 1998, the company launched its first independent graphics card, the i740. But just 1 year later, Intel decided to cancel its next generation and integrate graphics onto motherboards instead. The company's engineers were optimized for building fast central processing units, not the wide data paths and specialized circuits that graphics cards required. While NVIDIA and AMD invested heavily in GPU technology, Intel largely abandoned the space. When AI applications exploded in popularity and demanded massive GPU power, Intel had almost nothing to offer. Its attempts to catch up, including the $2 billion acquisition of Habana Labs in 2019, failed to produce chips that could compete with NVIDIA's dominant offerings. The company also lost ground in its core business. For years, Intel maintained a clear lead in chip manufacturing technology. It could make smaller, faster, more efficient processors than anyone else. That advantage was worth billions, because it meant Intel chips performed better than the competition. But in the 2010s, Intel began falling behind Taiwan Semiconductor Manufacturing Company, known as TSMC. Intel struggled with delays in advancing its manufacturing processes. Its 10-nanometer technology took years longer than expected to bring to market. Meanwhile, TSMC was manufacturing cutting-edge chips for Apple, NVIDIA, AMD, and other Intel competitors. The manufacturing crown that Intel had worn for decades passed to a company in Taiwan. As Intel faltered, its rivals surged. AMD, which had been struggling for years, launched its Ryzen processors in 2017. These chips offered comparable or superior performance to Intel's offerings at lower prices. Intel's desktop processor market share, which had been above 90%, began to erode. By late 2200, Intel's server market share had dropped from 98% to 77%. AMD captured nearly 20% of the market in just a few years. The trend continued downward. By the third quarter of 2205, Intel held just 72% server unit share and only 61% of server revenue share. In less than 7 years, the company had lost roughly a quarter of its dominance in the lucrative data center market. Then came the leadership crisis. In January 2021, Intel's board fired CEO Bob Swan and brought in Pat Gelsinger, a former Intel executive who had left the company years earlier. Gelsinger arrived with an ambitious turnaround plan. He wanted to transform Intel from a company that only made its own chips into a foundry that would manufacture chips for other companies too. It was a radical shift. Intel would compete directly with TSMC and Samsung in the contract manufacturing business. Gelsinger's strategy, which he called IDM 2.0, required massive spending. Intel announced plans to build new factories across the United States and Europe. The company started construction on a $20 billion manufacturing complex in Ohio, with plans to eventually spend $100 billion on up to 8 fabrication plants. Intel hired aggressively, expanding its workforce to 132,000 employees, larger than it had ever maintained even during its peak dominance. The plan was to regain manufacturing leadership through sheer investment and willpower. Gelsinger laid out an audacious roadmap to deliver 5 advanced manufacturing nodes in 4 years. But the timing couldn't have been worse. Just as Intel ramped up spending, the personal computer market collapsed in the wake of the pandemic boom. People had bought laptops during lockdowns and weren't buying new ones. Intel's core business revenues fell. The company's gross margins, which measure profitability, sank well below historical levels. The foundry business itself was bleeding money, $7 billion in operating losses in 2000-2003, with billions more in losses continuing through 2000-2004 and 2000-2005. Intel was paying to build manufacturing capacity that didn't yet have enough customers to fill it. The financial strain forced difficult decisions. In August 2024, Gelsinger announced plans to cut 15,000 jobs, a 15% reduction in the workforce. The company slashed its dividend by nearly 66%. Intel separated its foundry division into an independent subsidiary to provide more transparency and potentially attract outside investment. Gelsinger's base salary was cut by 25%. The board grew increasingly frustrated. Despite the ambitious plans and heavy spending, Intel wasn't making progress fast enough. The company failed to develop a competitive AI chip to challenge NVIDIA. It couldn't secure enough foundry customers to justify the massive factory build-out. In December 2004, the board forced Gelsinger out. After less than 4 years in the job, he was given a choice: retire or be removed. He chose to step down. The company named 2 interim co-CEOs while searching for his replacement. 3 months later, in March 2025, Intel appointed Lip-Bu Tan as the new chief executive. Tan brought a different approach. He had previously led chip design software firm Cadence and had served as a technology investor. Tan immediately began cutting costs more aggressively. He announced plans to reduce headcount to 75,000 employees by the end of 2025. He canceled factory projects in Germany and Poland that Gelsinger had announced. He consolidated assembly and test operations, closing sites that were underutilized. Most importantly, Tan declared that Intel would stop investing in manufacturing capacity without confirmed customer orders. There would be no more blank checks. Every factory expansion had to make economic sense based on actual demand, not hopeful projections. The new strategy focused on what Tan called disciplined execution. Intel would build what customers needed when they needed it. The company would develop its next manufacturing node, called Intel 14A, specifically in partnership with large external customers, rather than building it first and hoping customers would come. Intel would also refocus on its core strength, designing processors for personal computers and servers, while being more realistic about the foundry ambitions. Despite all the turmoil, there are signs that Intel's manufacturing technology is finally catching up. The company successfully brought its 18A process node into production in 2205. This represents the completion of Gelsinger's 5 nodes and 4 years roadmap, a technical achievement that many analysts had dismissed as impossible. Intel's new Panther Lake laptop processors and Clearwater Forest server chips are being manufactured on this advanced technology. The question is whether technical progress can translate into business success. Intel also secured significant support from the United States government. The company received nearly $8 billion in grants under the CHIPS Act, the largest direct subsidy from the program designed to rebuild domestic semiconductor manufacturing. The government even converted some of that funding into a nearly 10% equity stake, effectively making Intel a national champion that's too strategically important to fail. Intel also won a $3 billion Department of Defense contract for secure chip manufacturing. The semiconductor industry is watching closely. If Intel can execute on its manufacturing roadmap and win major external customers for its foundry business, the company could stage a remarkable comeback. But if the foundry continues losing billions without gaining significant market share, Intel may be forced to abandon the strategy entirely and retreat to focusing solely on its own chip designs. The stakes are enormous, not just for Intel and its shareholders, but for American technology leadership. For the first time in decades, the outcome is genuinely uncertain. The giant that once seemed invincible is fighting to prove it, can adapt, compete, and survive in an industry it used to dominate. Whether Intel rises again or continues to fade will be one of the defining business stories of this decade.